Hello dear students, this is Ashwini S, Assistant Professor of Mathematics. The topic which we are going to discuss today is about Lagrange's mean value theorem and Taylor's theorem, which is of 3rd semester BSc Mathematics paper 1, Unit 2, Real Analysis 1. Now let us see Lagrange's mean value theorem for two variables. This theorem is very important for 5 marks. Statement. So we are going to consider f of xy to be a function which is satisfying two conditions. The first condition says it should be continuous in the closed domain D, and the second condition says the first order differential coefficient, that is df by dt, f of x comma y exists in the open domain D. If these two conditions satisfies, then f of a plus h comma b plus k will be equal to f of a comma b plus h into fx of a plus delta h comma b plus delta k plus k times fy of a plus delta h comma b plus delta k, where a comma b comma a plus h comma b plus k belongs to the domain D and theta is between 0 and 1. Now this fx is nothing but dou f by dou x, fy is dou f by dou y. Now let's see the proof. So we are going to define a new variable t as x is equal to a plus ht, y is equal to b plus kt, t lying between 0 and or equal to 1, where our h and k are constants. Now we get the function of single variable t as capital F of t is equal to f of x comma y. Now let's substitute the value for x and y, which becomes f of a plus ht comma b plus kt. Call this as equation 1. Now let us recall the Lagrange's mean value theorem, which we all know in first year BSc. The formula is capital F of b minus capital F of a divided by b minus a is equal to f dash of c, c being between 0 and 1. Let's call this as equation 2. Now, you know the value of a is equal to 0, the value of b is equal to 1, which on substituting gives me f of 1 minus f of 0 divided by 1 minus 0 is equal to f dash of theta, theta being between 0 and 1. Transferring f of 0 to the right hand side, we get capital F of 1 is equal to f of 0 plus f dash of theta, theta being between 0 and 1. Now from equation 1 we put t is equal to 0, t is equal to 1. So I get capital F of 1 is equal to small f of a plus h comma b plus k, and capital F of 0 is equal to f of a comma b. Hence our answer becomes f of a plus h comma b plus k minus f of a, that's equal to f dash of theta, theta being between 0 and 1. Call it as equation 3. Now we all know that if x is equal to a plus ht and y is equal to b plus kt, then a capital F of t can be written as f of x comma y. Now let me differentiate this using total derivatives. So capital F dash of t will be equal to d by dt of capital F of t, that is nothing but f of x comma y. So capital F dash of t is equal to dou f by dou x into dx by dt plus dou f by dou y into dy by dt. We know dx by dt is equal to h, dy by dt is equal to k. Dou f by dou x will be denoted as fx, dou f by dou y will be denoted as fy. Or f dash of t is equal to h into fx of, let's substitute for x and y. Then what we do is we will be substituting theta in place of t in equation 4. So capital F dash of theta is equal to h into fx of a plus h theta comma b plus k theta plus k times fy of a plus h theta comma b plus k theta. You know right hand side of equation 3 is f dash of theta. So let me substitute this value there. This on substituting gives me f of a plus h comma b plus k minus f of a comma b is equal to the right hand side of equation 5. Hence, our final answer becomes f of a plus h comma b plus k, that's equal to f of a comma b plus h into fx of a plus h theta comma b plus k theta plus k times fy of a plus h theta comma b plus k theta. This completes the proof. Now let's see this Taylor's theorem for functions of two variables. We are all aware of Taylor's theorem of one variable already. The statement says if x comma y is a function of continuous partial derivatives of nth order, then f of x comma y is equal to f of a comma b plus x minus a into fx of a comma b plus y minus b into fy of a comma b plus 1 by 2 factorial into x minus a whole square f double x of a comma b plus 2 times x minus a into y minus b fxy of a comma b plus y minus b whole square into f double y of a plus b plus so on. So let's solve a problem. The first problem says expand xy square plus x square y by using Taylor series on 1 comma minus 3 up to second degree terms. So let's write down the given equation as f of x comma y. So let me put x is equal to 1, y is equal to minus 3 in the given equation and solve. We get 6. Then fx of x comma y, that is partial differential of f with respect to x, gives me y square plus 2xy. Put x is equal to 1, y is equal to 3, we get answer as 3. Next we have to differentiate f partially with respect to y. So x becomes constant, differential of y square is 2y plus x square is a constant, differential of y is 1. Similarly, put the value of x as 1, y as minus 3, we get minus 5. So our next step would be f double x of xy, which is nothing but we have to differentiate fx partially with respect to x again. The first term becomes 0 because y is a constant. In the next term, 2y remains same. Differential of x will become 1. So you get 2y. Okay, 2y. So put x is equal to 1, y is equal to minus 3. We get minus 6. Now next we have to differentiate. Let me go back. Fy, you know fy is 2xy plus x square. So I am differentiating this again with respect to y. Second term becomes 0. First term will just become 2x. So substitute the value of x is 1. So our answer becomes 2. Next what we have to do is we have to find the value of fxy. That is differentiate fy with respect to x. Now let's see what is this fy value. Fy value is 2xy plus x square. I will be differentiating it with respect to x. I get 2y plus 2x. So substituting x is equal to 1, y is equal to minus 3. Answer becomes minus 4. Now let's write down this Taylor series form. So this is our equation. F of x comma y is equal to f of a comma b plus x minus a into fx of a comma b plus y minus b into fy of a comma b plus 1 by 2 factorial into x minus a whole square f double x of a comma b plus 2 times x minus a into y minus b fxy of a comma b plus y minus b whole square into f double y of a comma b and so on. Now let's substitute the formula. First of all, you know the value of a is 1 and the value of b is minus 3. So this, on substituting and simplifying, our answer becomes xy square plus x square y is equal to 6 plus 3 into x minus 1 minus 5 into y plus 3 minus 3 into x minus 1 whole square, that's because you have divided by 2, minus you have 8 by 2, that becomes minus 4 into x minus y into y plus 3 plus we have 1 by 2 into 2 gets cancelled, y plus 3 whole square plus and so on. This is the answer for second degree term. Now let's solve the next problem. Our next problem says find the Taylor polynomial of log of 1 plus x plus y at 1 comma 1 up to second degree terms. So the given problem is f of x comma y is equal to log of 1 plus x plus y. Here the value of a comma b is 1 comma 1 only. So f of 1 comma 1, put x is equal to 1, y is equal to 1, we get log 3. So differential of f partially with respect to x, differential of log of a function is 1 divided by a function. So I get 1 divided by 1 plus x plus y. When you put x and y as 1, our answer becomes 1 by 3. Now fy of x comma y also be is the same, which is 1 divided by 1 plus x plus y, which on substituting x is 1 and y is 1, I get 1 by 3. Now let me find out what is f double x of x comma y. This will be minus 1 divided by 1 plus x plus y whole square. Put x is equal to 1, y is equal to 1. We get minus 1 by y as answer. Now fxy also remains same. It is minus 1 by 1 plus x plus y whole square. Put x is equal to 1, y is equal to 1. We will be getting minus 1 by 9 as the answer. So we have left with f double y of x comma y. This also on differentiation will give me, it is of the form 1 divided by x or 1 divided by a function. So it's minus 1 divided by 1 plus x plus y whole square. This again by putting x is equal to 1 comma 1. Now fy of 1 comma 1 is equal to minus 1 divided by 1 plus 1 whole square, which becomes minus 1 by 9. Now let's write the Taylor series expansion formula, which you have been looking into every problems. So a is equal to 1, b is equal to 1. So let's substitute all the values. So we get therefore log of 1 plus x plus y is equal to log 3 plus of x minus 1 into 1 by 3 plus y minus 1 into 1 by 3 plus 1 by 2 factorial is 1 by 2 itself, x minus 1 whole square into minus 1 by 9 plus 2 into x minus 1 into y minus 1 into minus 1 by 9 plus y minus 1 whole square into minus 1 by 9 plus so on. Now there are few terms where it gets cancelled. On cancellation and simplifying, a final answer becomes log of 1 plus x plus y is equal to log 3 plus 1 by 3 into x minus 1 plus 1 by 3 into y minus 1 minus 1 by 18 into x minus 1 whole square minus 1 by 9 into x minus 1 y minus 1 minus 1 by 18 into y minus 1 whole square plus and so on. So far we have studied Lagrange's mean value theorem and Taylor series formula with that problems. So the references which I have used is textbook of BSc Mathematics by G.K. Ranganath. Thank you dear students.